Hi, good morning, guys.
Good morning, sir.
Good morning. Let's do one thing. Meanwhile, if everybody joins, solve one problem, find the reactions, and then based on those, we will try to find the horizontal and vertical thrust. Find the reactions at A and B.
Is that point load, sir? 10 kilonewton?
Yeah, point load. What about Priyadarshini or Anita? She's not at all coming to class.
I think she is seeing the recording, sir.
Okay, that's fine. We just try to complete this lesson by the time. There may be a couple of minutes. If everybody wants to join, they will join. How much you are getting?
RA is 34, sir.
34.
76.
Horizontal thrust.
1 minute, sir.
How much? What is the horizontal thrust, guys? Why it's taking so much time? Let us say this is point C. Priyadarshini, have you find? Vishnu, what's the value? Obviously, Vishnu, if you want to find horizontal thrust, what you should do? You have to take moment at point C. 0, right? So, what's the problem that you guys can face here? What's the horizontal thrust? Sorry, your voice is too low. For this, either I can take moment at C by looking from the left side or by looking from the right side. Right? So if I look into the right side, what is the reaction at B? 76, anti-clockwise. So 76 into, what is the distance? 10. And because of the horizontal thrust, clockwise, if it is clockwise is positive, it's into 4 because of the UDL load, clockwise plus 10 into 10 by 2 will be equal to 0. How much you're getting? You can take any side. You can take left side or right side. Both answers should same. It's not like you should get different answer. You have to get the same answer. If you solve this, how much you're getting? If you are looking at the left side, then how it will be? Reaction at A is nothing but 34. 34 times 10 clockwise positive because of the horizontal thrust anti-clockwise minus h into 4 because of the loading is also anti-clockwise. So minus 10 times, if it is 4, the remaining will be 8. That will be is equal to 0. Whatever the side you consider, you should get the same answer.
65, sir.
In both, are you are getting 65 or?
Yes, sir. Both.
In both, you should get 65. Obviously, here it will be on the right side direction. Here it will be on the left side direction. Right. These things did not take much time. It's much easier. Tell me one thing. How you found this? Like, are you writing any equations directly, or are you finding them directly without writing the equations itself?
Equation, sir.
By writing the equation.
Yes, sir.
Or without that? If I'm in your place, what I think that, okay, because of 10 kilonewton, what is the reaction of here? Or what is the reaction of at point B? I can say, right, load into, what is the opposite distance? If I'm finding the reaction, what is the opposite distance? Total is 20.
18, sir.
Practically write down 18. Divided by, right? What I will do, plus here, because of this load, there's a total load, 10 into 10, 100. 100 into what is the opposite distance? If I take the area of the globe, will be at the centroid. 10 by 2, 5. That means what is the opposite distance? 5. What is the total length? 20. If I'm in your place, this is how I'll find the reaction at A. Have you done like this, or again you have written the equation like this? So if more than one load is acting, just like in this type of cases, finding the reactions like this is simple way of doing instead of writing the big equation. The same concept you will use even if you write the, just like your state exams, your university exams, if you write the entire equation, that's of no use. But finding of due to individual forces, that will make our work simpler, much simpler. Okay. Now, even though what I am discussing, that's not come, but let's discuss still. Let us say, if I'm taking a point in an arch, let us say you have to find out the radial shear and axial thrust. So from the name we can identify axial thrust. At that section, let us say this is the section I am talking about. Axial thrust means is oriented along the towards the cross section, as we have already discussed that. This is always towards the section. Always the compression forces will be there. So let us say this is the axial thrust, AT, and the radial shear, the unbalanced force here. This is what nothing but your radial shear. Now, our task is to find out these two values. Let us say we have to find out radial shear and axial thrust. How can I find out them? Let us take example of this. And let us say that we are going to find out axial or radial thrust at a distance of 5 meters from left support. So first let us draw that section from A to the axial thrust where we want to find. And let us represent the reactions here first of all. This is upward. How much we got it? 34. In the horizontal thrust, we have obtained it as 65. And there is some unbalanced force here. How much it will be? Sorry, applied load 10 kilonewton. So, on whatever the section you want to find out, here, if I'm drawing the free body diagram of this section, as I'm telling you, whenever you are drawing the free body diagram, you have to represent the all possible types of forces. So, as I'm separating section, let us say AD. Even for the section AD, at A we have represented the forces. At D also we have to represent. Why? Because we are separating it from the remaining arch. And at D, again, find out the unbalanced forces. What are the unbalanced forces? At D, can you tell me what can be the vertical reaction that is possible at D? Look into the total vertical forces. Total, how much vertical force is there? 34 at A vertical, 10 kilonewton downward. How can I balance this?
24 upward.
That will upward or downward? 34 is upward. So how you will
Downward,
balance
sir.
it? It will be the remaining downward. What is the magnitude? 24 kilonewton. And what about the horizontal reactions? 65 that is acting on the right side. So how will we balance it?
Stay on left side.
Isn't it? Now, the section at this point will be, it is not truly horizontal section, just like the beam source section will consider truly as vertical, but as it is a arch, there is some inclined position. So first of all, I'm redrawing the section here. This is what my section at point D. On that section, what I know? I know that this is my horizontal reaction at that, and this is my vertical reaction. But what is our interest? Our interest is to find this one. We have to find out along this section what is your axial thrust, and along the parallel to this surface we have to find out what will be your radial shear. And if you are getting confused now, imagine if this is your beam, what will be the direction of your axial force? Like this. If this is your section, the axial force will be always perpendicular to the section. So that's why if this is my section, perpendicular to that I have represented the axial thrust. And parallel to that surface, we'll represent it as the shear. So that's why as it is in some curvy shape, that's why we are representing it as a radial shear. For that we know, let us say this is 65, this is 24. Let us assume that this angle is theta. First of all, can you tell me, is there any way to find out this angle theta? Imagine this is a, let us say, parabolic arch. How can I find out that angle? We know the relationship that y will be is equal to 4h by L square into x into L minus x. So how it varies with respect to x, that is what, nothing but your slope. Along the x, how it will vary, that is what, nothing but your slope, that will be equal to, differentiate with respect to x, how much will get? 4h by L square. For the differentiation, to differentiate it, you will get it as L minus 2a. If take x inside, Lx differentiation L, x square minus 2x. At what section we are finding? We are finding it at 5 meter. That implies what will be your slope? Rise is how much? 4. What is the total length? 20 square. What is the total length? 20 minus 2 times x to the. Tell me how much you are getting this theta value?
0.4.
How much? 0.4.
4, sir. 0.4.
0.4. Now tell me, somehow you know the value of theta. If you know the value of theta and you know the at that section horizontal and vertical force, what can be your axial thrust?
Resultant, sir.
What theta I should consider here? This is, let us say there is some section I have considered. Let us say there is some arch. Let us say that I have taken a small portion over the arch, ds. And for that, along the horizontal, this is the dx, this is the dy. Dy by dx, whatever we are finding. What about this slope? I should write it down. Tan theta, can I write it down? From the formula, what is tan theta? Dy by dx. If this is very, very small, in our case, we are getting this value as 0.4. That will be is equal to tan theta. That implies theta will be considered as tan inverse of 0.4. Let us assume that we have got dy by dx is equal to 0.0004. Can somebody tell me, if I take tan theta is equal to 0.004, can somebody tell me this, what is the tan inverse of 0.0004?
0.0229, sir.
0.0229. So as this angle, theta, as it goes smaller and smaller, at some point of time, theta will be is equal, nearly is equal to tan theta. Or we might have seen theta is nearly is equal to sin theta. But in our case, 0.4 is a considerable value. So instead of treating as theta, we have to take it as a tan theta. That implies what will be your theta? What will be your slope at that point?
21.8.
What is the unit? 21.8.
Radian, sir.
It's up to you. It's in your calc you will have, right? At the top you might have seen whether you should calculate your angle in degrees or whether you should calculate in radians. How you have calculated this angle?
Degrees, sir. 21 degree, 48.
It is at 21.8 degrees. So now you know this angle theta. So can you tell me what is your axial thrust? If this is theta, what about this value?
90 minus theta.
As these two are perpendicular, it will be 90 minus theta. Now you know this value 65, you know this value 24, and you know the slopes. What will be your axial thrust in this case? The names can be anything, you can put any names, but if you look into that, what I know is that mechanically, if I look into the mechanics of this, what I'm telling you, there is a horizontal force and there is a vertical force, and I'm asking you to find out the forces on some other planes which are situated at an angle theta from the horizontal. It's nothing like resolving the forces to that plane. Now what you should do, resolve the forces of 65 and 24 along the planes AT and RS. If you resolve the 65 force along the axial thrust, how you will get it? Resolve this force along this plane, how much you will get it?
65 sine.
60. What is the angle? It is adjacent cos theta. So the plane is making an angle theta. So the plane it is theta. So here it will be cos theta. We have seen it, right? If there is a force and this is angle theta, what is your horizontal component? If this is our horizontal component is ortho offset. Why? Because whichever the plane is making an angle, we treat it as a cos theta. So for 65, 80 plane is making angle theta. So what is the, if you resolve this 65 cos theta? What about because of this 24 force? Resolve this. How much it will be? 24. Making a same plane, right? Is making an angle. So how much it will be? 24 into cos of minus theta. So what is the axial thrust there? 65 cos theta plus 24 sin theta. Similarly, can you tell me what will be your radial shear? The same way, resolve the forces.
65 sine theta
Okay, and then
plus 24 sine 90 minus theta.
if you resolve this force, this will be in the upward direction. If you resolve this force,
Yes,
this
it
will
is.
be.
Yes, it is.
So what will be your radial shear in this case? That will be 60 sin theta or 5
Theta
theta is positive
minus
no
24.
sine of 90 minus theta cos theta.
Oh, I see.
Here, if you want to find out these values, no need to by heart any formulas. It's just the mechanics. What you should do, at what are the point you want to consider, draw the free body diagram until that point, and then find out the slope at that section, and then resolve the forces along that orientation. That's it. Here, for the simplicity, we have considered the left side. Even at this point, if you want to find out, you can consider the right side section free body diagram also. You will get the same answer. So in case if they might have asked this axial shear and radial, they will not ask in the exam, but these are not as difficult as it looks like. If you know the forces at any section, it's simpler to find out the forces at any section. Now, again the same thing, find out the reactions at the support for a linear arc. Can you please find out the reactions?
5, sir.
5, sir.
Yes, clear it is 5 and 3. And what about the horizontal thrust?
25, sir.
How much?
25.
How? Oh, it's 25. It's not a 3-hinged arch. It is a
Is it
2-hinged.
0, sir?
Obviously, the reaction will develop, isn't it? As it is a support, obviously horizontal thrust will develop. But unlike the previous case, I'm not saying this is a hinge point. If this is a hinge point, then you can take the moment is equal to 0. But I'm not talking about I haven't given any hinge. Then can you find out this horizontal thrust?
Or the entire arc, sir.
Type of arch we are talking about? Linear arch. What does that linear arch represents?
The bending moment at any point is 0.
0. So even though I have not given moment at this point, not only at this point, you can take moment is equal to 0 at the rate any point. And then you can find out the horizontal thrust. So in question you should, or you can understand that if there is a simply supported beam subjected to point load, what will be your bending moment diagram?
Linear.
Linear.
Yeah.
Triangle shape is
Shape is also linear. You can think that okay, the simply supported bending moment and the arch shape is also equivalent. So the bending moment is equal to 0 at any point. So based on this logic, you can find out the horizontal thrust. You can take it at any point. Then you will get the horizontal thrust as 25. Yeah. Now, similarly, can you find out the support reactions?
Is there a hinge, sir?
Yeah, there is a hinge. Yeah, there is a hinge. Think about it and let me know what are the challenges that we might face in this. Is it simply we can find the reactions or where the complexity might arrive here?
The horizontal distance is unknown, sir.
Yeah, they are unknowns here. But if I take moment at point C is equal to 0, then I can find out them, right? So what is the parameter that we want to find out here? You try to solve it and then you will get to know what parameter you need to or are you guys doing or not?
Sir, but sir, when we take reactions at, bending moment and any support, however, one component is being unknown, sir.
Please continue. What about the vertical reactions? Sorry, I could not hear. Can you please type it? Is there any difficulty in finding the vertical reactions?
Is it 200, sir?
Is it 200? Is it right?
But it is not symmetrical, no, sir. The arch is not symmetrical.
Yeah, that's what I'm asking you. Why? So let us say, if I'm talking about moment at point A is equal to 0, let us say this is the horizontal thrust. Do you agree that horizontal thrust should be same on both sides? Or will they be
No,
different?
sir.
They will be
Different.
same or they will be different. Look at
Different, sir.
look at the equilibrium equations. Other than those two, are there any other forces those are acting on the horizontal direction? Other than horizontal reaction at A and horizontal reaction at B, are there any other horizontal forces?
No, sir.
Then if you add summation of those two, you should get 0. If there are two forces, summation of them should be equal to 0 means how much? They both should be equal and
So both should
opposite.
be equal and
That
opposite.
the reaction horizontal thrust at A and B both will be same. It doesn't matter because there are no other horizontal loads. Now, If I take moment at point A is equal to 0, let us say this is the vertical reaction. Because of this VB, anti-clockwise minus VB times 40. Because of this slow time, clockwise plus 10 times, how much it will be? 10 into 40 into 40 by 2. But if you take the horizontal thrust here, see, there is a difference at those levels. So because of this H, moment will develop here also. What is that magnitude? H into 3 clockwise. So plus H into 3 will be equal to 0. If the supports are oriented at this level, if the support is oriented at this level, what happens because of this thrust? No moment will develop. So this will not come into the picture. So then you can say that the vertical reactions are 200 at both the support. But at present, it is not. So what is the thing? First, we have to find out. First, we have to find out these distances from here to here. What is the distance from here to here? 40. Total is 40. So from here, let us say this is C dash. Can you tell me what is AC dash and what is C dash B? If I add both, I know that I'll get 40. You got the point? If you know them, then obviously there are other things can be find it out. How?
Take some theta value, sir. But however, theta will be.
You just tell me what are the, see, there are two ways of knowledge for every person. One thing, whatever we have studied, and from that we have to apply. And the second thing is that even if you don't know it, but from the core elements, like from the basic mechanics point of view, somehow we should able to find out. Like just like I have discussed, if I tell you that even though I don't remember what is axial thrust and radial shear, but if I given these forces and if I ask you the forces along this plane, if you know the simply how the forces can be resolved, then based on that also you can find it out. So first of all, whenever a problem that comes to you or anybody asks a question, do not always think about from the point of view of what you have studied. Instead, think it from the basic knowledge. Just by thinking about it, can I able to find out or not? So those are the things that we have to develop. Then only the questions can be quickly answered, or even though it's not strictly related to the whatever we have studied, that will help us in some way. So try to think about in that way, it will be very helpful. Now, what is the equation that we know? If it is a let us assume that this unit is a parabolic arch. I know one thing, what will be my relations? I know that y will be equal to 4h by L square into x into L minus x. All right. How can I find it out somehow? By using this equation, just think about it. Can I find out this length?
Instead of L minus x, we can substitute as 47.
Instead of, I know that at this point somehow I know that it is a 4 meter.
Yes, sir.
By using this value and by treating this as unknown, by using this equation, try to find out the quantities. Use this equation and you know this height as 4 meter and take this as unknown and tell me whether you can find out something or not. Just think about it like any equation that I can apply. Let us say at this point, what can I denote it? At x equal to 0, my y is equal to 0, right? At point A, obviously my x is equal to 0. That means I can say that my y is also equal to 0. Let us assume. if I use this equation, will it help on any way? Substitute y equal to 0 and x equal to 0 and h.
Sir, H value.
Take h as 4 meter and then see how much we'll get it. If you take h is equal to 4 meter, then how much we'll get it? 0. Here 0, here
Zero,
0, 0, right? It will be of no use. And obviously, rise at what point we'll take it? We'll take it as L by 2. So what you do another thing. That is, let us assume that at x equal to L by 2, we know that y is equal to 4. Again, can you apply the same equation and tell me, are you able to find out anything? Are we able to find out how much you are getting if you substitute x equal to L by 2 and y is equal to 4? How much you are getting?
Sir, in this case also H is equal to 4, no, sir?
In this case, yeah. Now, let me tell you one thing. Let us say that, imagine if this is your arch, okay? And let us say this is your P. In this case, it is equal to 4 meter. And from here to here, how much it will be? That's this is L by 2. Obviously, this is L by 2. Right? Now, as this is parabolic arch, we know what is the variation? The rise or the ordinate at any point. That means if I take a section x from the left support, then the corresponding ordinate at that point is y. Isn't it? Now, y can be written as how much? 4h by L square into L minus x, isn't it? Now, if I want to apply this equation at this point, what is your x and y? X is 0,
Y is also 0.
At this point, what is your x? Total
L
length
by 2.
L by 2, x equal to L by 2. And what is your h? 4 meter. And what about this point? X equal to how much?
L.
L. And what about y?
Y is 0, sir.
Y is 0. Now what we are trying to do is that, imagine this arch is made up of, like, see, if I take L values differently and H values differently, obviously, even if it is a parabolic arch, I can form a different house, isn't it? If I change the length and if I change the central rise, obviously, I can have different types of arches. Like this, isn't it? I can draw n number of arches, right? But what is our motive here? According to our guess, we don't know what is our length. So that's why use this relation, these three, and if you substitute in this equation, they will be of no use. Why? Because they both are satisfied, obviously. We know that at x, we know the y. If these two we know, then this equation of no use. Now what I am telling you, further continue this arch. Same arch I am continuing. Imagine that from here it is started, it has 0, and then I am continuing the same arch. Can I continue? Now after that, what happened? According to our case, at this point we know. At this point, what is the thing? We know that your y is equal to, this was the neutral point, y is equal to 0. What about this? As it is going below the line,
minus
according to our case, what is the given case? It is 0. From here to here, how much it is far down? -3.
3.
Still, can I apply this equation or not? The same much it is continuing. The length is same. Then my y is given as -3. That will be equal to 4 into what will be your rise? Your rise can be treated as 4. Length will be say L square x into L minus x. Now in this case, What is the L that I should consider? Or what is the X that I should consider here? X is started from this point until this point. Can you tell me what is the length? Sorry. Shit. Are you seeing my screen?
Yes, sir.
Visible.
Sorry, it got shut down by some issue. Just wait a second, couple of minutes. See, the point I'm conveying is, sorry. See, what is in our arch is given at A and at B. The levels are different, isn't it?
The screen is not visible, sir.
Yeah, I think it's restarting. Can you take 10 minutes of break and then we'll continue?
Yes, sir.
Let's
Yes.
continue from 10:10 or 10:15.
Yes, sir.
And let's take it up to
Yes.
12 and wind up the arches and cables today.
Yes, sir.
Yeah. Take a break and we'll continue.
Okay, sir.
Welcome back here. I've been trying to connect my network. It's not connecting. Just wait for a couple of minutes. Sorry for the inconvenience, guys.
No problem, sir.
You guys took your breakfast.
Yeah, just now, sir.
So you are all completed your BTech or
Yes,
in the
sir.
fourth
Yes,
year?
sir.
Completed?
Yes, sir.
Okay. I think in COVID, your 2 years might have gone then.
I completed long back, sir.
Okay. So which year you have completed and what you're doing?
Sir, I'm currently housewife, sir.
Yeah,
So,
okay.
just started to prepare for my TRB exams.
Okay. And what about others?
I think Vishnu has completed some 2 years back, I think so, sir. He's also preparing now, started to prepare just now, I think so. And Priyadarshini also same. She's also housewife, I guess, sir.
Yeah, so
Yes.
what's your daily schedule? How you have started preparing? Have you make a list of formulas that you guys know by heart?
Yes, I'm making some short notes, sir, while taking notes and going through question papers.
Yeah. I-
Still have to revise, sir. The revision strategy, we are following some new techniques, but it is not working out.
What's the new technique that you are following?
That is after some regular intervals, like 1 week practicing or revising the same subjects again, but we are not doing it continuously, sir. That is the main problem, sir. Drawback.
So I felt like, what the difficult task is to study for continuously. See, we can study for 1 week, we can study for 2 weeks, but studying for a couple of months continuously, it's like, fatigue. You might have heard the term, right?
Yes, sir.
But
Yes, sir. Actually, we also have household works, also having some personal commitments. So
yeah,
among that only we have started to prepare. So it is a bit difficult
have
for
you
us.
have you guys seen the news that one of the UPSC aspirant has studied only 15 minutes a day and he cleared the exam? Have you heard of this news?
No, sir. 15 minutes a
No,
day.
sir.
But for
15 minutes.
UPSC, they're studying around 15 hours, 10 hours.
No, 15 minutes a day. I have seen a news. I don't know whether it is fake or original, but I have seen it. I think in shorts I have seen it. And then I was surprised a lot. 15 minutes a day. He is not a human being. What I used to do is that while I'm preparing, I used to solve at least a paper in a day. It's not like taking the like previous year's questions, take it and solve it. It's not like that. It's about take one full paper and try to solve it. So what
Paper in
happens
the
there
sense
is
that
that,
will be all the subjects, sir.
yeah, combination of all the subjects. See, in exam, they don't ask like topic wise, right? It consists of each and every topic, each and every subject. So imagine if the exam consists of only one subject, do you think getting a full score is easy or difficult? In whatever the exam, you are having only one subject. Why? Because as it is only one subject, everything will scroll up our mind, and it's somewhat easier for us to remember and to application anything. But how many subjects you guys have right now? 15, 16 around?
Yes, sir.
Yes, 10 subjects for TRB, sir. Around
Yeah.
10 subjects.
Even
But
what do you think?
But it includes around
You guys
15
have
subjects.
completed, yeah, you guys have completed all the subjects in 4 years, or we have all completed in 4 years, right?
Yes, sir.
So the studying everything and applying everything in a 3 hours of time. So what do you think? How much practice we need then? Have you ever
No.
forgotten ABCD? Have you forgotten any order?
No, sir.
After AB, have you ever spoken D? Why? Because what do you think the reason is?
Practice.
How many times you might have used it? How many times we might have practiced from childhood?
Countless.
Yeah, that's what I will say that that's the logic behind it. Even though it's very difficult to recall that number of times coming to our schedule, but yeah, the main heart of the problem is practice.
Yes.
We have to study them regularly, and then at least twice a day you have to practice a paper. So what happens when you practice a paper? It's like you have to treat yourself in practicing. When I started practicing, I used to practice a paper thrice, once in a 3 days. And I feel like whenever I commit the mistake, I think that, okay, this is the mistake that I have committed here and I won't commit in the exam. You know, that's how I think and I have prepared. But unfortunately, what are the mistake I thought I will not repeat in the exam? Same mistake I have repeated in the exam, and I have lost around 2 marks. Do you know how much it will cost of 2 marks? In the rank as well.
Many ranks I have.
It will be a couple of like, let me tell you. I think my system is connected to the network. So at one point of time, even if you commit a marks of 0.1 range or 0.2 or 1 marks range, it will cost us a lot. It will. It will grab us the opportunity of getting PSU. It will grab us the opportunity or missing the opportunity of getting a state commission exams. We might not qualify for at least 1 marks. These are the things that's gonna happen. So that's how whenever you practice a paper, what are the marks you are getting there? Those are your final marks that you will get if you give in the exam too. And I've been telling you so many times, silly mistake is not a silly mistake. If you commit a silly mistake, again that will cost us a lot. Getting these things or telling these things are very easy, but how do you get rid of those things? Doing a thing continuously is a very hard thing for a human being. Whoever will crack it, they will crack everything. That's where the idea of exams, at least for our exams. It's connected. So make a schedule, take a paper, download it, and at least give your 2 hours of time, 1.5 hour time, and solve it completely. And treat it yourself that you're doing an exam. And then what are the marks you're getting there, and treat that as your final marks. Then only we can improve. If you do not treat that those are your final marks, then you won't improve in the final exam.
Yes.
What about if
What about?
if we started now only, what is the preparation strategy, sir? Are we
No, I'm not at all clear. Your voice is not at all clear. What about? Can somebody please ask him, convey to me by somehow?
I think he will type, sir.
Yeah, fine.
Sir, but without completing every subject, can we go through take a paper and do a test, sir? We may not know many concepts in that, no, sir.
How many subjects you guys have completed as of now? How many you guys have completed?
No, around 4 to 5 subjects, sir.
Even that's fine, right? Take a paper and try to solve those 5 subjects only. And
Okay,
whatever the
sir.
subjects that you guys have not completed, trying to give you a thought. You might have the basic idea, right? Even if you have not completed now, at least as we have studied in our BTech, we have some idea. So what do you think? You try to, as I told you, right? Even if you don't know the concept, try to think about them. Then when you try to think about them, that's where your thinking process will improve. When you think of something that you don't know, that will help us a lot. It doesn't mean that every time we have to think it that way. As you guys have not completed all the subjects, if you do that way, then if some new question gave in the exam, then you guys might able to think it. It's just the application only. Yeah, I told you, please select the subjects. What are the subjects you have started? Try to solve them. What I mean to say is that please practice the previous year questions and treat yourself that you are in the exam hall. Then only the silly mistakes will become recorrected, and we know how fast the things we apply. Obviously, if I give you one question from one subject, you can solve it. 10 questions from 10 subjects, for our mind, it will take time to recollect them and it will take time us to apply them. So if you want to reduce that time, practice of questions, previous year's questions. For that, we have to by heart the formulas. There is no way to it. Every day, even before the sleep or even after the wake up or during the sleep, during lunch, whenever you're having no good time, try to recollect the formulas, whatever you have studied. Whenever you're recalling, definitely you will face at one formula. Like this formula is not remembered by me, then you go through them and recollect as many times as possible so that it will be remembered forever, at least till the exam. After that, nobody cares. So by hearting formulas are very good thing and it's a necessary thing. And to wherever there are empirical formulas, you will have a lot of empirical formulas in, I think, open channel flow and even in transportation. So there are a lot of, and even in environmental also, there will be some formulas that you guys have to by heart. So those things you have to by heart with the unit. There is no option left for you. So the main mistake that people commit in there is that you will remember the formula, but you will forget the units. Let us say that if I ask you what is the Young's modulus of elasticity for concrete, what is the formula? The formula for Young's modulus of concrete,
5000 root FCK.
FCK.
Yes,
Is
sir.
it an empirical formula?
Yes, sir. Empirical formula.
Or in which unit we have to substitute the FCK?
So the compressive strength. Characteristic compressive strength.
Yeah. You substitute FCK in MPa,
Okay, sir.
then only you will get your Young's modulus in MPa.
Yes, sir.
Right? So these things you should know. You have to substitute in MPa, then only you will get an MPa. But if you forgot this, then if you substitute the other unit, then you are gone. So if somebody asks you what is the compressive strength of concrete, let us say, as I'm telling you, right, what do you think? In most of the times, even if you take the all students marks and if you do the distribution, it's like definitely it will follow the normal distribution. Now, this is what median marks. It's not necessarily 0. It can be a median mark, 50% probability. Now, you know, you can see this range. In this range, even if your marks are plus or minus 1, it won't make a much difference. But see this range. In this range, even if your marks are around plus or minus 0.5, lot of people will come here. Your target is to, you should not fit in this range. Why? Because most of the people, or what do you think the distribution percentage will be? Let us say it is nearly 95%. This portion will be 2.5%, and this portion will be 2.5%. So this is how the common distribution of the marks that people will get in any exam. If you be in this portion, it is of no use. Your target is to achieve more than 95% or more than 95%. Then only we will have the possibility of getting into something. In this range, as I told you, the plus or minus 0.5 will make a lot of difference. In this range, getting 0.5 marks is easy, but in this case, getting the additional 0.5 will be a lot of difficult. So try to be in this range and create a difference. What other people will do. And one more thing you should think is that you are practicing and she is practicing and Vishnu is practicing. What is the contribution that you are giving extra so that you get an additional advantage? What is the thing that is? You three are practicing, you are taking the same coaching, you three are following the same approach. I'm just talking for you three of you. You three are discussed and you three have studied the same topic. But where the difference in the marks comes from? By committing or by avoiding the silly mistakes? By doing the time management? If I give you a question, one more question, and if I give you 10 minutes of time, I can tell you that everybody can give me the right answer. What if I reduce it to 0.5, let us say 30 seconds? Even the simple problem, if I give you 30 seconds, what do you think? Do everybody will give me the correct answer?
No, sir.
Why so? Because
Time management.
in our mind, obviously, it's a kind of sensation will develop that okay, the time is very less and we have to be very fast. So whenever you are going fast, you have to be 200% careful. What are the chances of committing accidents with the 200 kmph or with 50 kmph? 200 kmph, obviously, it can be a fraction of a second that we can commit an accident. That's what happens here also. If you want to do a question in it without committing any silly mistake, is that practice. That's why I'm telling you to practice as many as question papers. It should feel you like you're in the exam. Then you might reduce your tense during the exam and your efficiency will increase. Okay.
Yes, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
Another thing is practice. I can tell you that those who have practiced more, they will get a good rank. That's it.
Yes, sir.
Studying things will be different, very, very difficult. Now, let's come back to our problem. So here our task is to find out if total length is given, what is this portion and what is the portion of this amount. If you can do this, then everything can be cleared, right? Now, if I given you from here to here, it is 40. And what about from here to here? Obviously, both supports are symmetric, then I can say it is 20 meter and here it is 20 meter. But the point is they are at the different levels, this support and this support. So our task is to find out if from here to here, from our question it is given as 40, then out of this 40, what is the distance from here to here? The distance from supports at equal level. And then here the curves might go on. So as I'm telling you, if I'm applying from here, this is from X and Y. In the same way, can't I apply that? This is my X and this is my Y. Here also the curve is started from 0, 0. Rotate the same curve and started from here. This is what your X and this is what your Y. And this is what my equation, my rise, Y equal to 4h by L square into X into L minus X. Even if you start from here and if you start from here, just like let us say that you're making a sprint. If you let us say the total sprint is 100 meters. From if you started and if you come here, you have completed 100 meters. And if you complete one more sprint, you add 100 meters to that. So the reference axis is this one. And again, the reference axis can be considered as here. Now the point is, we know from here to here, what is the rise? According to our question, it is given as 3 meters. At what distance the rises rise? That means from here to here, what is the distance? That is not known for us. To find out, let's apply in this formula. Y is how much? The rises happened as -3. That will be equal to 4 times. What is the rise that we can consider? The total rise that we have considered, 4 by the length is, that is what the unknown, into X. That is what the unknown, into length is given as L minus, or if you want to simply remember, if you remember Y is equal to 4h by L square into X into L minus X. If you take this L to the left side, L square is directly proportional to H. So your rise and length of the parabola, they are inversely proportional to each other. So we can say that if you are having different lengths, L1 by L2, that will be equal to under the root H1 by H2. Even if you don't know, or if you don't want to complicate the thing, with this simple formula also we can find it out. Now, let me draw it here. Imagine that from here to here, I will treat it as one parabola. From here to here, I will treat it as another parabola. This size, let us say I have given it as 4 meters. From here to here, I have given it as 3 meters. If I treat this as one parabola, let us say parabola 1. From here to here, let us assume the distance is x. For x1, or for x, what is the rise? Rise is given as 4 meter. Let us assume this is what your another parabola 2. From here to here, if the distance is x, what about this distance? Total length is 40. So this is 40 minus x. So for 40 minus x, what is the rise? 7 meter. For x, it is 4 meter. For 40 minus x, what is the rise? 7 meter. So what is the relationship between these two? So what is the relationship from L1? Let us substitute x, or L2 will substitute 40 minus x. That will be equal to, what is the rise if you take the parabola segment 1? 4. What is the for segment 2? It is 7. So from this, can you tell me what will be your x value? How much we are getting?
17.225, sir.
How much?
17.225.
So for the given arch, from here to here, 17.2. And then from here to here, how much it will be?
So 1 minute previous slide, sir. How is calculated x, sir?
How?
Once- How we calculate x value?
I am telling you that this is your one segment parabola. This is your another segment, right? These two are combined at this level. Right? Now, if I don't use this formula, what I should do, as I'm telling you, in this formula, what I should do? In this formula, what is our task? Our task is, we are representing this is x, this is y, isn't it? What is
Yes, sir.
our unknown? Our unknown is nothing but a length of the segment. What is meant by length of the segment? It is not the overall length of the arch, but the length is represented from 0 to 0. Do you agree? If you are representing this formula y equal to 4h by L square into x minus L minus x, what about this L represents? L represents the distance between 0 ordinates. So this is what the length represented as a L, length between 0 ordinate, isn't it? Now, let us say if the length between 0 ordinate is somewhere here. This is what you treat it as a L, right? Do you agree? So this is the 0 ordinate, this is the 0 ordinate. So length between them is L. But what is given in the question? They have given that from here to here, what is the distance?
40.
40 meters, isn't it? For this 40 meter, what will be your ordinate? From here to here in our question, if it is what the 0 level, can I take it as a -3 according to us,
Yes, sir.
right? If this equation is applicable, it can be applicable at each and every point, isn't it? It will be applicable here, it will be applicable here, at each and every point, it should be applicable, right? Now, if I apply this equation, what will be my y? -3, that will be equal to 4 into, what is my rise here? My total rise is given as 4 meter, right?
4 meter.
4 divided by, what is the length? Do we know the length between 0 to 0 segment?
40.
No, sir. Don't know, sir.
40 is from here to here, but what is the L? If you
L is
formulate
unknown,
this,
sir.
from 0, distance between 0 to 0 segment, L square. What is the X? At what point you are considering this is? From A to this point, what is the length we have to consider? 40. 40 into length is again unknown, L minus 40. Can you quickly tell me what is the length that you are getting here? Are you directly getting the length, or it will be in the form of some equation?
Form of equations, sir.
Right? Quickly, can you find out how much you are getting? Is it much difficult? Minus 3L square 16 160L minus 6400. So if I take the right side, 3L square plus 160L minus 6400 is equal to 0.
26.6, sir, and minus 80.
How much?
26.6.
So instead of complicating them, think, let me review it. You should not get 26.6, but I will review it and let you know. But you can use this formula to 17.2. Now, let us talk about the maximum bending moment. Let us say that I am having a moment of magnitude m. So how can I say that? What is the condition that I should apply to get maximum or minimum? Let us say I'm having some moment equation as 30x minus 6. Can you tell me at what point I can have the maximum value? At what point I can have the minimum value? You might have find out, right? What is the maximum bending moment you might have seen. If you are talking about strength of materials, which condition you guys have applied? What is the condition that you have applied to get the maximum bending moment?
Maximum ordinate, area under load.
Area under the load, or let us say that this is what my loading curve. And if I draw the shear force diagram, let us say I'm getting somewhere like this. Let us say A, B, C, D. Can you tell me at what point I might have the maximum bending moment? I am not giving you any values, but I'm asking you at what point I might have the maximum bending moment.
At point B and C, sir.
Why?
So
Why
middle
point B and C?
is
Ordinate is maximum.
Which ordinate is matching? Not only talk moment, I get function of x. How can you find out that at what point I'm minimum value? At what point I'm having the minimum value? The common logic that we will use.
So f dash of x is equal to 0, sir.
At the point of maximum deflection, what do you think the slope is? At the point of maximum deflection, what is the slope?
0, sir.
0. It's not only true for movement, it's not only true for deflection, for any function. If you take any function, if you differentiate that function, f dash of x by, here what is the function in terms of x? Dx will be equal to 0. And that means we are applying slope of that function. This function can be bending moment, can be deflection, can be shear force, anything. So wherever there is a maximum, the slope is equal to 0. At that point, we will have the maximum value or minimum value. According to mathematics, I don't know whether you guys remember, to get either maximum or minimum, we'll find out f double dash of x. If it is less than 0, or if it is greater than 0, based on this, we will define whether it is the maximum value or minimum value. Through mathematical terms, maximum means it is a positive value, minimum means it is a negative value. But according to us, if you are talking about the movement, what does the positive represent and what does the negative represent? If you are talking about the bending moment, positive represents the sagging moment. It doesn't matter whether it is positive value, negative value, whether it is sagging or rocking, it doesn't matter to us. Only it matters to us is that it is a maximum value. That's it. For that, what we should do? If my function is in terms of x, we have to do dm by dx is equal to 0. That means wherever dm by dx is equal to 0, at that point there is a probability that you will have the maximum bending moment. Either it can be a sagging moment or it can be a fogging moment. What is mean by dm by dx? What do you think the dm by dx will be?
Slope, sir.
Yeah, slope of, yeah, what is this represents? Slope of bending moment diagram is equal to how much? The slope of BMD diagram can be represented as shear force. Shear force at any point. Shear force at any point is equal to the slope of the bending moment diagram.
Yes, sir.
I think you guys might have solved this in your chemical material.
Yes, sir.
Now,
Yes.
we can see by looking at this diagram, there is a variation of shear force and also there is a variation of shear force. That means these are crossing 0 points. So either at this point or at this point, you might have the maximum bending moment. I can't say exactly at this point or at this point, but I can truly say that either at this point or at this point, you have maximum bending moment. You can see what is the slope between point A to B. The slope is constant or the slope is equal to, it's not 0, it is equal to constant, it is having some value, or the slope is equal to 0. If I take a
No.
inclined line, you are having the slope. Let us say this is what the bending moment diagram. What is the slope at every point?
Increasing, sir.
Whatever the point you take, I'm talking about the slope. Either you take this point, you take this point, you take this point, you take this point, you take this point. What is the slope of all those points?
Same, sir.
Slope is same.
Positive slope.
Slope is same. Your shear force should be
Constant.
constant. See, that's what happens here. In between A to B, if you draw the bending moment diagram, the bending moment diagram will be linear. If it is linear means the slope is constant. If the slope is constant means your shear force is constant. That means wherever your bending moment diagram is linear, your shear force diagram will be constant.
Constant.
If your bending moment diagram is of 2 degrees, then what will be if you differentiate with respect to x? What will be the order of the function? Let us say your bending moment is in terms of 2x square minus x. What is the differentiation of this?
4x, sir.
4x
Minus
minus 1. What is the order here?
1.
1, sir.
1. dm by dx is nothing but a shear force. That means if the bending moment diagram is in the form of parabola, what will be the variation of your shear force?
Linear variation.
First order. That means that's what I'm telling you. If your shear force is linear, increase 1 more degree to get the bending moment diagram.
Yes, sir.
So based on this logic only. So similarly, if I'm giving you, let us say, some circular arch, it doesn't matter whatever may be the loading. Let us say if it is a hinge here, what is the bending moment here? 0. What is the bending moment? 0. What is the bending moment? 0. If you draw the variation of bending moment, it might be like this. This is what the variation of bending moment diagram at this point 0, at this point 0, at this point 0. In between these two, there will be a maximum value. Let us say it is a circular arch. Now, if I ask you at what point I am having the maximum bending moment, how can you say it? For this question, the basic logic is same. Whenever you want to find the maximum value, the first thing is that take the differentiation is equal to 0. Now here the point is, if it is a circular arch, I told you, representation of point on the circle will be easier with respect to the theta. What is the ordinate? If you remember, in previous classes, we have seen x equal to r into 1 minus cos theta and y is equal to r sin theta. So the coordinate at any point on the circular arch can be defined by using the angle with respect to the center. So in the same way, if you want to find out the bending moment equation, it will be easier to write the equation in terms of the angle theta. So if you want to find out the maximum value, what we should do? Differentiate with respect to the theta. If you differentiate with respect to the theta, then you will get 0. That means you will get some angle theta. So if you are talking about circular arch, whatever the equation you will find out, every equation will be in terms of theta. So if you want to find out the maximum, you have to differentiate that function with respect to theta. And whatever the value of theta you will get, at that value, either you have the maximum or minimum value. Says that we have to by heart is that if it is a 3-hinged arches, if it is subjected to UDL loading, then the maximum bending moment will be, if it is having the radius r, then the maximum bending moment will be WR square by 8. If it is a simply supported beam, you know what is the maximum bending moment if the length is r, WL square by 8. Just like the same, if it is radius r, WR square by 8. In beams, you know, it will exactly acting at the point of middle. But here the maximum bending moment will occur at an angle of 30 degrees. Write down the moment equation and differentiate with respect to theta, and that's where you will get the theta value. So if you see the diagram, this is what the variation and this is what the variation. Similarly, on the right side span, again this angle is nothing but 30 degrees. So these are some standard cases that we have to by heart. If it is a circular arch with UDL loading, the maximum bending moment is WR square by 8, and it will occur at an angle of 30 degrees. So I told you these are the cases you guys have to by heart. If you want to sit in the exam hall and if you want to do it, that will be a waste of time. Until and unless there are no standard cases, we have to derive, but these cases we have to by heart. Right? Now, let us see the temperature changes. What about if it is a parabolic arch? If it is a parabolic arch, we know the relationship between ordinate y equal to 4h by L square into x into L minus x. So it will be convenient to express with respect to the x magnitude. If it is a circular, you treat the unknowns in terms of theta. If it is a parabolic, you treat the unknowns in terms of x value. Now, let us say there is a 3-hinged arch, and if the temperature rises, can you tell me what happens? If the temperature rises, can you tell me what will happen to the arch? Think about in general and let me know what will be the effect can be. If there is a temperature rise, what will happen? The members will try to expand it. If the expansion is prevented, then resisting forces will develop. Now, look at the supports A and B. Will they allow any expansion?
No, sir.
No, right? Why? Because they are in suppose they won't have an expansion. Then how the expansion can happen in this case, if it is possible? Look at the hinge point C. Except the supports A and B, are any or along the curvature of the arch, except the points A and B. Is there any constraints? Are there any constraints on other points? No, right?
Yes, sir.
So if at all there is a temperature changes, what will happen? except the point A and B, the temperature will rise, or the change in variation will be like this. Now, the defined will be always can be defined with respect to the peak value. So the maximum rise will be denoted with respect to the hinge point. So let us say this is what the rise in temperature, let us say. From here to here, let us say this is what the central rise. Because of the increase in temperature, delta H can happen. Now, what is our next task? The first task is to find out if it has rise, then how much rise it might happen, isn't it? In general,
Yes, sir.
how you will find out the rise? How you will find out the change in length because of the rise in temperature? In general,
We can use the y is equal to formula, sir.
we can use.
And that y is equal to 4h by L square.
No,
There, instead of h, we can use h plus del h.
No, we'll come back that later on. But the point is, now this is due to temperature change, isn't it? If this is due to temperature change, how you will find out? In general, we have to obviously use the alpha, isn't it?
Yes, sir.
If consider a bar of length L, if I am thermal expansion coefficient alpha, and there is a change in temperature delta T, what do you think the strain happened in the system? What is the strain happened here? Alpha into delta T. This is what the strain happened in the system. So if you want to find the what is the change in length, that's how you will do. Strain into total length. That means alpha into delta T into L. So this is how you are gonna find it out. Isn't it? Now, how we are gonna apply the logic here? Here it is a truly along the length, that's why we have simplified out alpha into delta T into L. But in this case, how can I find out this central rise? I cannot use, as you said, H, there is no member here H. It's just the representation of the rise at the central point. So I cannot take this H as a reference point to find out the variation. If there is a member along the orientation H, then I can find out, but the orientation of the member is in the form of arch. So that's why I cannot directly include this H, but how can I? Here, what is the reference angle that we have considered? The reference angle that we have considered as a L. So just like the same thing, you can consider the reference axis as anything. Let us assume if this is the point C, just for the simplified purpose, even though these things are not required, I'm just telling you so that if there is somewhat complexity observed, you can able to solve it. So before the expansion, this is what the original length, isn't it? After the expansion, what happened? The point has moved to here, right? Now, what is this value? How much it has moved from here to here? So if I draw that in an enlarged way, for the point C, point B, and this is what the, let us say, some C dash. And this is what the delta H that we are gonna find out. So first we have to find out how much distance it has moved in a perpendicular way, right? Now, let us say this is some, let us say some X. How can I find out this EX? Just like based on the same logic, alpha into delta T into L. Imagine there is a circular thing. And if you are taking in two arcs, angle between them theta, what about this angle? Can you tell me? What about the distance between these 2 points?
R into theta.
R into theta, isn't it? So just like the same thing, because of the temperature rise, if this is delta theta, what can be this value, this length?
R
It is nothing
into
but. So in this case, strain happened into BC. That's what I can write it down. So what is this? I can write it down. The Cx is nothing but a Bc times what is the strain happening in the system? Alpha into delta T.
Delta T.
What about this BC? Can I find out what is the length of BC? From here to here h, from here to here L by 2. What about the length of BC then? Length of BC is nothing but a L by
Root
2
of H square.
plus h square under the root. Now I'm not replacing this value, but you know. So what is the Cx value? BC into alpha into delta T. But what is our requirement? Our requirement is not to find out this, but our requirement is to find out this value.
Delta H.
So for this, how do we find out? If this is angle theta, if this is perpendicular, what about this angle? This angle can be theta. So if this distance is fine, if this is 90 degrees, this distance can be also be fine by using the sine theta. So this CC dash can be written is equal to the, or this delta H, the rise will be equal to whatever the value we have found out, Cx divided by sine theta. In the exam, they don't ask you this type of question, but how you are going to do this and all not required. But at the end of the day, you have to find out your rise in temperature or rise in the, because of the rise in temperature, the peak will move to the distance of 4h square plus L square divided by 4h times alpha T. This is what you have to remember at the end of the day, delta T. If there is a rise in temperature of delta T, the change in rise will be equal to delta H. If there is a decrease in temperature, the rise will be in the downward direction. Now, as the temperature changes, the point C, either it will rise or it will decrease. Now, due to that, there will be any effect on the support conditions. Because of the rise in peak or decrease in the peak, will there be any effect on the forces? There will be any effect or not. If these two supports are at the same level, this reaction has the same values, let us say. If I'm considering parabolic arc subjected to UDL loading. If both supports are same level, what are the support reactions? WL by 2, WL by 2. Now look at this value. It is depending upon the length of the span only. Is it depending upon anything of central rise? No. If you remember, what about your horizontal thrust? If you remember, the horizontal thrust will be WL square by 8H. Now you can understand the horizontal thrust is depending upon the length of the arc
Central rise.
as well as the central rise.
Central.
If this value is changing, then obviously your horizontal thrust will change, isn't it?
Yes, sir.
Now you can compare these two. They are directly proportional or inversely proportional.
Inversely
That
proportional.
means if your rise is increasing, what about your horizontal thrust?
Will
Decreases.
decrease.
If your central rise decreases, then your horizontal thrust will be increases. If there is an increase in temperature, the central rise will be H plus delta H. That means what about your horizontal thrust?
Will decrease.
If the temperature decreases, what will be the rise? H minus delta H. That means whatever your central thrust will be
Increase.
increases. Now, what will be the rise in value? Or if I want to ask you, what is the change in horizontal thrust? Now I have found out what is the change in rise, delta H. Similarly, if I want to find out what is the change in horizontal thrust if there is a temperature change. How can I find out? Whenever if you want to find out the changes, you have to go for the differentiation. Now in the present case, I know what is my centralized WL square by 8H. If you want to find out the change with respect to H, what I should do? Obviously, I have to differentiate that function with respect to H. To differentiate, how much you will get it? Minus, what is the H inverse? Minus 1 by H square. So minus 1 by 8H square. What does this minus represents?
Decrease.
Opposite. That means if your H is increases, your change in will be minus, that means it will be decreases. So the proportionality will be decreases minus. Now, what will be my change in thrust then? My change in thrust will be equal to minus WL square by 8H square into change in drive. So minus WL square by 8H square. Now we know the formula, how to find the rise in temperature. Just now we have found out the formula is 4H square plus L square divided by 4H times alpha times delta T. So if there is an increase in temperature, you have to take this as H is 10 kilonewton. Now you found out DH is equal to minus 1 kilonewton because of the increase in temperature. Now your new thrust will be 10 minus 1, that will be equal to 9 kilonewton. If there is a decrease in temperature, your DH will be positive. If delta T will be negative, if it is positive, that means your H will be
10 plus
10
1.
plus 1, that will be is equal to 9 kilonewton. So this is a simple case for loading, just like anything. As it is a UDL loading, that's why we have simply can be written as WL square by 8H square. But if the loading is not simple, like if the loading is points load, in that case, we cannot define horizontal thrust by using the simple equation. That means if I give 2 different loads, 3 different loads like this, can I get a formula? Just like here, like WL square by 8H square or WL square by 16H square.
Yes.
For the standard cases only, we can write down the formula like WL square by 8H square in this case. But other than the standard cases, we cannot simplify this equation. If we cannot simplify this, then we cannot express this in the form of equation. So always we have to try to remember for the standard cases. And remember for the standard cases, then that is more than enough. So even if they don't give you the UDL loading, you find out the horizontal thrust based on that, then substitute the value here and then multiply by the DH. That's it. Here.
Can you explain the last one again, sir? If they give point load?
If there is a point loads, then what will happen? Can we simplify this H value? Just like in the previous case. Just like here, what we have done initially, we have taken WL square by 8H, right?
Yes, sir.
On this, we have to differentiate it with respect to H. Isn't it? Now, if it is a particular value, even my horizontal thrust will be a single value. Can I differentiate it?
No, sir.
Can I differentiate this function? No. In that case, then I find out my change in the horizontal thrust. In this formula, I can, if I don't want to use the formula, then how can I find out the change in horizontal thrust? Did you got the difference what I'm telling you right now? In the previous case, as it is a standard case, we have written WL square by 8H, and then we have varied with respect to H, differentiated it, and then we have found something. But what happens now? If I have given you the standard set of values, like just think about it. Think about the ways that I can find out. Can we find out or we cannot find out? Come on, come on, come on. Now let me tell you, rise is also given. 0.17 meter. Can you find what can be the change in rise? First of all, tell me, is that question clear? What is the question that I given you? Is that understood?
Sir, if h is a constant value, then we cannot differentiate to know, sir.
We cannot differentiate, but how can you approach it? We cannot differentiate that, right? But how can I find out my, still I want to find what will be my change in horizontal thrust? Can I find out delta H?
Delta h is given in question, sir.
Yeah, I can, no, if there is a rise in temperature, we can find out the delta H, isn't it? By using 4H square, by
Yes,
using
sir.
formula.
Yes, sir.
Then what will be my new configuration? This is my new configuration, isn't it? And the loading is also acting on this. Now, find out the horizontal thrust because of the H plus delta H. If you know delta H, you know this value H plus delta H, then can you find this
Yes,
H1 and
yes.
can you
Yes, sir.
find?
Yes, sir. Yes, sir. We can find.
Original case is H1 by treating central rise as H, find out the horizontal thrust as H. Treat H plus delta H, find out the central rise as H1 by using the equilibrium equation. Now you find out. Then what is the rise? Can't I write what is my change in horizontal thrust? Can't I say H1 minus H?
Yes, sir.
Yes, sir.
This is what truly based on the values. But previously we have done with respect to the some type of function.
Yes, sir.
WL square by 8H, that is a function with us in the form of H, then we have found. But here there is no function. Directly we have found out the values and then we are finding the change is nothing but a. So that's all about the 3-inch ratchets. Now, if you come to 2-inch ratchets and just like the 3-inch ratchets, can you find out by using the equilibrium equations itself? If it is a 3-inch ratchet, so we are having the
Equation.
additional equation. What is moment at hinge is equal to 0. But what about here? Total number of unknowns 4, equilibrium equations 3. That means somehow we have to create one additional equation. Right? Now, what my advice is that if 2-inch ratchet is given, there are some standard cases that we have to by heart. Other than the standard cases, if they are given anything, it will be just a waste of time to solve this problem. Why? Because it's not completed in 1 minute or 1.5 minutes or 2 minutes. If it's not a standard case. And there is a possibility that people will commit lot of mistakes. So that's why if 2-inch ratchets are given, then if we can remember for some standard set of cases, then that will be more than enough. Clear?
Yes, sir.
So let me discuss those cases. Now I am talking about parabolic. If it is a parabolic 2-inch ratchet, if it is a UDL loading, what if it is a 3-inch ratchet? What is the horizontal thrust? What is the horizontal thrust for a UDL loading for a 3-inch ratchet?
W square by 8H.
WH square by 8H. Similarly, even for the 2-inch ratchets, it will be WL square by 8H. You will get the same reaction. If it is a central point load, P, if it is a parabolic, then the horizontal thrust will be 25 by 128 into PL by H. Just remember or by heart these cases, then more than enough. If it is a circular, if it is a UDL, then the horizontal thrust will be 4 by 3 W R by pi. If W is the intensity here. Similarly, if there is some force P, as I told you, if it is a circular arch, any point can be defined by an angle theta. If the force P it is at an angle theta, then your horizontal thrust will be P by pi sine square alpha. Now, if the load is exactly at the peak, what will be the theta value? If the load is exactly at the peak, what is the
90.
theta value? 90. If theta is equal to 90, yeah, then if you substitute, how much you will get? Okay.
Yes, sir.
If you can by heart these 5 cases, then that is more than enough. And don't go look beyond other than this. Why? Because if you look beyond these cases, then again, that will be a waste of time. Even if I tell you how you have to find out, then again, that will be waste of time. Even I have not studied. If I can explain you, we can, but as I'm telling you, it's a waste of time. If these type of questions are asked in the exam, it's simple that you can ignore it. Nothing else you can do. Now there is one thing that definition that you have to learn, that is Eddy's theorem. It is that now, let us say this is your any type of arch subjected to the loading. Now, if you represent the linear arch over this, if it is a point loads acting on the section, let us say if point load is acting on the section, how the bending moment variation will be? If simply supported subjected to central point load, the shape of the bending moment will be triangle, right? So what will be the shape of the linear arch then? Linear arch, I'm telling, we have discussed, right? Where the bending moment is equal to 0. If there is a central load acting on the arch, what can be the shape of the linear arch? The shape of the bending moment diagram. What is the shape of the bending moment diagram? Point load.
Parallel.
If it is a point load,
Linear, sir.
triangle,
Triangular
yeah,
triangle.
right? Now, if you represent a point, some point, let us say point X on the arch, then according to this theorem, they have discussed that bending moment at any point X, that is proportional to the intercept. What is the intercept between these two? What are the point you are finding? You have to take the intercept. Let's say this is what intercept I. So along this variation, the intercept will be I. So with respect to this intercept, you can understand the variation between the X. That means if they ask you at what portion the bending moment is maximum, at what portion the bending moment is minimum, then what you can do is that superimpose the bending moment diagram, and then you can identify at what portion you can have the maximum bending moment. And you can say wherever you have the larger intercept, at that you can say that maximum bending moment can be occurred. If we can remember this much, then this is more than enough. Don't go beyond whatever we have discussed about the arches. Clear?
Yes, sir.
Sir.
At what time you guys have another class?
Yes, the building.
Okay. I think, did you guys get a sense that we are about to complete?
Sir, almost
Cables are,
every topics.
yeah. See, cables I don't take not much time, not more than 15 minutes or 30 minutes. And then we'll discuss some simple things that we haven't discussed in the initial stages or for determinate things. For some cases, we'll see how to find the deflection, rotation, and we'll find out for some standard cases, and then we'll wind up. We have very much discussed briefly about indeterminacy. We have very much discussed about trusses. We have very much discussed about influence line diagrams. Similarly, slope deflection method, moment distribution method. And then we have also clearly discussed about stiffness method and the flexibility method. Only the thing that left in our hand is that just solving the problems. Practice as many as we can. That's it. Then you will also get clear. Okay, shall we continue in the next class? Most probably we might wind up in the next class. If not, 2 more classes. That's it.
Yes, sir.
Okay, let's stop here. Okay, thank you. Bye.
Thank you, sir.
Thank you, sir.